forgot my light. Wrong button. There it is. Wrong mode. Let's see. 3 up. Okay. There we go. Maybe that makes a difference. Okay. Let's lock this so I don't do something stupid. And I think this is good. Okay. Music. There's no music playing. Cool. That looks good. We're about to get started. All right, so yeah, we can get started. We ended yesterday with looking at the Rustonomicon implementation of VEC, which is an array list in Rust, and probably the most oft used collection, you could say. Kind of like an array in JavaScript, or, you know, a VEC or list in what do I think about? Closure, a list in Closure, all that good stuff. So yeah, there's a couple things I still wanted to take from that project, from Rustonomicon, and copy it over into our VEC implementation and our code base, so that we just kind of have it in an easy place and we don't have to keep going back onto the Rustonomicon in order to get it. So let's just get a couple things out of the way. If you want to follow along on our GitHub, it is there. And then the Rustonomicon that we're starting with is here. And then after we go through the Rustonomicon a little bit, we are going to jump into implementing a stack, most likely, if I have time. So that's kind of the basics for today. All right, cool. So what did we do so far? Let's switch back to code. This is the VEC implementation, pretty much copied from Rustonomicon. We did do our own array list already, but this is what we're doing to learn how to actually implement it using unsafe blocks. So what we did so far is we have our struct defined. We have our sync and send defined for our VEC. The reason that works is it's basically just saying if T, the generic type T, implements send, then we can say we can implement send for VEC automatically, and the same thing for sync. So that's all those things say. We have our constructor. We're not supporting zero size types right now. And we are initializing that with a dangling non-null pointer, which has 0 allocation, and then 0 length and 0 capacity. The next function is the grow function, which is to grow the inner array. I'm not going to walk all the way through that. And then we have also already done push, adding something to the end of the array list, and pop, which takes something off of the end of the array list, right? So it is a last in, first out queue, you could say, right? And then we have our insert and remove, which is just inserting at an index and then removing at an index. We also went ahead and copied over the drop implementation, and this is just to clean up the memory. As far as I know, this mostly would not be required. Like in our original array list implementation, we probably would not be required to implement drop. It would just deallocate all of those structures by itself. So in this case, since we're actually modifying and using raw pointers, we need to actually dealloc ourselves. So that's that. And then we have our dref for vec and dref mute for vec. So basically what these two things give you is, by implementing dref and dref mute, it means that we can actually, you can kind of see it here, we can get an automatic, you could say, transformation or conversion into a slice, and then we get all of the functions on slice, which there are a lot of them. And that is essentially where a lot of the functionality that we even use on the native vec in Rust comes from. So that's where we're at so far. We're going to jump back to the Rustonomicon to get to the next section here. Let's see, where are we? We got deallocating, we got dref, we got insert and remove, and then we have into-iter. So yeah, let's just open that up, talk through it a little bit. Let me find the right place. Yeah, perfect. So switch to browser, take that off, and we'll zoom in a little bit and move over, and that should be a nice view for everybody. Okay, so at this point, we're going to write the iterator for the vec. So iter and iter mute are already given to us because of the magic of dref. So technically, we would be fine just doing those, right? We could just move on. I don't know how helpful the into-iter and drain part is, but I've also wondered this before, like the difference between calling iter and into-iter. So that is something that I wondered. Okay, so into-iter consumes the vec by value and can consequently yield its elements by value. In order to enable this, into-iter needs to take control of vec's allocation. Into-iter needs to be double-ended as well to enable reading from both ends. Reading from the back could just be implemented as calling pop, but reading from the front is harder. We could call remove 0, but that would be insanely expensive, right? Because removing something from the front of an array list is O of n. It requires a mem copy every time. Instead, we're going to just use putter, read, to copy values out of either end of the vec without mutating the buffer at all. Okay, and when they say buffer, I believe what they're talking about is what I would call like the inner array, right? The underlying memory block that you're using underneath your array list. To do this, we're going to use a very common C idiom for array iteration. We'll make two pointers, one that points to the start of the array and one that points to one element past the end. Okay, let's think about this. When we want an element from one end, we'll read out the value pointed to at that end and move the pointer over by 1. When the two pointers are equal, we know we're done. Note that the order of read and offset are reversed for next and next back. For next back, the pointer is always after the element I want to read next, while for next, the pointer is always at the element it wants to read next. Yeah, that makes sense. To see why this is, consider the case where every element but one has been yielded. Right, so that's why it starts at one element past the end. The array looks like this. Sure, if E pointed directly at the element it wanted to yield next, it would be indistinguishable from the case where there are no more elements to yield. Although we don't actually care about it during iteration, we also need to hold on to the vec's allocation information in order to free it once it into iter is dropped. Right, so that's the main thing, is that if you call iter, you're not consuming the vec, but it's actually an into iter. It sounds like you're actually consuming the vec and dropping it afterwards. So that's the difference. So we're going to use the following struct: pub struct into iter, buff non-null, cat capacity, use size, start, const t, and const t. Okay. So this is what they're using for into iter. I don't know why I always sit in that position, but like I sit in this weird position. I wonder if it's because my mic started getting lower, and so I started thinking that I needed to crouch. Let me try to retrain my brain a little bit here. Okay, let's see. No crouching. No crouching. So we're going to use the following struct. We already read that, and this is what we end up for initialization. Okay, so interesting. So we're creating an into iter struct for t, and then we're going to impl into iterator for vec t. So the into iterator, I'm going to say, is the actual trait, and we're just defining this struct as in order to hold on to our pointer from our vec, the capacity of our vec, so that we can actually know how long it is, right? I'm sorry, not the capacity. Well, the capacity of our vec, but it's the size, essentially, you know, of the buffer. And then we have a const to t and a const to t. And so I've seen this as a mute before, the star mute. I'm guessing this is just like a raw constant pointer. I don't know. Not familiar with that syntax. Maybe they'll explain it. 1 second. Okay. Cool. Okay, so impl into iterator for vec, right? So we have our type, which is the inner type of t. We have our into iter type, so they're just new typing those. I'm not sure why yet. It's possible that that's required for the trait implementation, because I'm trying to see where they're passing that item type. I don't see it. Okay. and then you just actually implement the n2iter function. So yeah, let's just type this out. I think it'll be good practice to type this out ourselves. Okay, so let's switch to code, and we're going to impl the n2iter. So we're going to start with, excuse me. Oh, my head was itching. Okay, we're good. We're going to start with an n2iter struct. And we have our buff, which has the non-null pointer, very similar to, well, actually exactly the same as our vec type. And then we have our use size and our start. And that's the const t. And end is const t. Compile time, constants, compile time, evaluable functions, and raw pointers. Yeah. So it is a type of constant raw pointer, which I guess makes sense. We're not mutating it. So unlike, let's see, well actually we're not using a raw pointer up here, but as an example, here's a raw pointer, raw mutable pointer, and that's just a raw constant pointer. Okay, that's what I assumed it was, but I just haven't dealt with this stuff before, so it's all a little new. Impl t into iterator for vec t, and our type is item. See, this is, I'm not so sure why they mutated the type, but we'll just maybe it'll come up. So they're new typing t, and then they're new typing into iter, so we can drop the sorry. So we can drop the generic param below. I don't know if that's required or not. Okay, so yeah. So here's a really good tip too on the difference between this and the deref. Like if you look at the deref implementations above, you know, the deref just takes a reference to self, the deref mute takes a mutable reference to self, and this takes an owned self, right? So that's a good tip that we are going to be consuming this. So let vec equals manually drop new self. Okay, make sure not to drop vec since that would free the buffer. Yeah. So we don't want, so this is interesting. I've never had to do this before, but basically it's saying do not because we're consuming the vector right here, right? Rust usually would say, okay, you consumed it, you're done, we're going to drop this vec, and this is saying we'll drop it ourselves, do not drop this vec, otherwise our underlying pointers aren't going to be valid, right? So yeah, so now we're just pointing. I don't know exactly why they bothered doing it this way, but that's fine. I probably would have wrote this a different way, but we can change it if we want to. All right, and so now we have our unsafe block to actually do an into iter. All right, and this is our, it's just, again, instantiating it, right? Initializing it. Initializing the iter. Okay. Cap. Fearless memory lake. Hey, how's it going? It's funny that they did that syntax cap, because we can just do this, right? Like, why not just do that? And if you're gonna do cap or buff puter, I don't understand why you wouldn't just do. Maybe it's because it's unsafe. All right, we'll start with what they are telling us, make sure it compiles, and then make little changes to see if we are not understanding the syntax correctly. How's it going today, Sandal? So we're getting our puter is puter, and our puter as puter dot add len. Okay. So real quick, what did we actually do just there? We nope, Rust Analyzer already is like, you could just say cap, dude. You don't have to say cap. So we initialized our n2 header struct. We set the buff as the pointer from the vec. We set the capacity to the same capacity. Makes sense. We set our start as a raw pointer, right? We're not using the non-null wrapper on it anymore. And then we set our end as that same raw pointer if the capacity equals 0, which we already know if the capacity is 0. Obviously there's no elements in there. And that's just our dangling pointer that non-null gives us. And then we have the other case, if there is a capacity, then we're going to do our end pointer again as the block after our last pointer. So that's why we're just adding the length to our pointer. So that's that. We gotta get some manuals here. Okay, the trait iterator is not implemented for vec into iter t. Okay. Why are we getting this? Oh, okay. It's because we actually have not implemented it. So it's right. So it actually won't compile anyway at this point, which is a little disappointing because I kind of wanted to refactor this right now to make it look nicer. Manually drop should just be a missing use. Yeah. Yeah. You think you could tell me where manually drop came from instead of just giving me a useless error? Would that be okay? Really? Come on, guys. Come on. You can do better than that. Let's see if the build gives me an error. Or tells me where to get manually drop. It does. Look at this. Help. Consider importing one of these items. Yeah, it's going to be I'm going to say core mem or stud mem. What do you think? Not core. I'm going to say it's stud. I'm going to say it's a stud mem manually drop. It seems happy enough about it, so we'll go with that. Okay, so we implemented into iterator, the into iterator trait for vec. And now we actually have to implement iterator. Wow. We have to impl iterator for the into iter struct. So obviously there is some special part of implementing into iterator that requires these, because otherwise why would you do this? Are you with me? Are you with me on that? Yeah. I don't understand why you would do that if it wasn't required to implement into iterator. So I don't know, a little weird to new type. Once we don't have any red squiggly lines, we'll try deleting one of these and see what happens. But for now, we'll just keep going. So the next thing that we have to do is impl our iterator. Might help if I actually put my generic type param, and if I didn't do that, but that's okay. All right. So we have our type item. Again, they're new typing T as item, probably required by the implementation of this trait. First time I've really come across that. And our next, which people who've used Rust and iterators should be familiar with, is our actual consuming operator. And we're going to just say self.start equals self.end. So basic thing, self-start, self-end. Again, these are just pointers to the start and the element at the end. How about that, huh? How about that? Okay. 1 second. Then we're gonna return none else. And we get to do a little bit more unsafe. And we have a footer read. And we have, okay. So remember, we're taking that first block. So our next is the forward iterator, and we're going to do next back, which is the other side. Okay. Cool. So self.start equals self.start offset. And right now, for anybody joining that doesn't know what's going on, we are following along the VEC implementation in Rustonomicon because we implemented our own array list, which VEC is an array list. But we just did it kind of what I would call fakely. We just used a VEC underneath the hood because we couldn't actually do it without unsafe Rust. As the title says, I am a noob, and being a noob, I'm a few months into the language. I've never really touched unsafe. So I didn't know how to do all of the memory operations that I needed to do in order to implement array list at a low level. And so we're working through this implementation from Rustonomicon because it's going to have pretty much all of those low level operations that we want for when we implement the rest of our data structures. So once we finish this and we were confident that we could do this for all of our other data structures, we can reference this while we implement a stack, which I'm hoping to get started today. Did I say stack? Is that what I put in the thing? I said stack, right? It's funny. I actually meant to do Q. I mean, an array list is just basically a stack. So, I mean, it's a stack with a few more things on top of it, depending on the interface that you want. It's like a slightly fancier stack. So, I mean, we could implement stack just for the heck of it, but I don't know how exciting that would be. But we could do it anyway. Okay, 1 second. Okay. So the other part of the iterator is the size hint. And that is going to be self.end minus self.start. Again, those are just raw pointers. Divided by the size of the type, which is min size of t here. And then we're gonna say when someone, right? So obviously iterator uses this internally, this whole size hint thing. I haven't read it. I haven't read the docs on it, so I don't know why they do that. It makes sense. They kind of want to know probably how big this whole thing is. Probably helps them do some optimizations. Okay. So now we're going to implement the double-ended iterator. And really all that is since we already have iterator implemented, this is just iterating from the end of our vec. Okay, let's go here. We know them, don't we? Okay, not really. Apparently not. There we go. That might help. What was the thing that I did? Ooh, okay. Good to know. Good to know that a pound sign just selected that for me. Okay. Okay. Double-ended iterator for into iter struct. I forgot the forward. The forward. Oh wow, that's a good one. Okay, and this is called next back, and I'm gonna try and this is basically the reverse of what we did before, and it's going to use the same check to say if there's nothing in our data structure, then we just return none. Else, we jump into some unsafe, and I'm just going to try to figure this out instead of looking at the book for a second, because it shouldn't be that hard, right? It shouldn't be that hard. Okay, so our self.end points to a block after the last element to start with, and then successively goes back. So we actually need to update our self.end. So that's going to be self.end dot. Okay, I actually don't know, because it's a pointer. It's not just a number. Okay, so they give you an offset method. I was trying. Skill issue. Okay, so they give you an offset method, and then of course we're just going to read that value out. So that's that, and let's see if that gets rid of all of our red squigglies. It does. Sweet. Yeah, so that tells me that we should have a clean build. We do. And now I actually want to delete this new type because I don't know why it exists. There you go. So it is required by the trait, right? Let's see, we should be able to... There we go. Not all trait items implemented, missing item. Cool. Okay, so that's why you new type it. How about it? So you're required to have the n00bery like that. Now, it does make me wonder if we deleted one of these. I'm gonna guess we're gonna get, well, we're gonna get several errors, right? Because we're depending on it. But I was just wondering if it was gonna give me an error there. No, it just gives me an error in my implementation. So maybe they don't actually, enforce the fields in your n00bery struct, which would make sense for different data structures. Okay, good deal. And then we need to impl drop for our n00bery. And we want to do this because we did the manual. We told Rust, trust me, bro. We told Rust to trust us that we are going to drop the vec ourselves, right? So once we're done consuming the whole vec, we finish the iterator, we're gonna dealloc ourselves. We don't have like a reference to that vec anymore. That would have been like my naive way of going about this, would be like, oh, maybe I should just have a reference to that vec and then I can just call drop directly on the vec myself. That's not how they did it here. Maybe that's for a good reason. I don't know. But it's going to mostly mirror our drop for our vec. For that and mute self. Okay. So that's just dropping any remaining elements because you don't have to use the whole iterator. And then, so it just consumes the rest of the iterator. And then we're gonna do very similar to our other implementation. If I remember right, we'll look at the difference in a second. We're just gonna dealloc. So our dealloc takes the footer and the layout. Whoops. Okay. And we're probably gonna need some typecasts, right? Yeah, okay. Oh yeah, we don't actually have a pewter in here. I forgot. It's a buff. I call it a pewter because I think it's cooler. Okay. Not like that. Not quite, guys. Not quite. Okay. As pointer as a raw mutable pointer. Okay. Self.buff.as. Okay. That looks fine. It's probably just because I deleted buff before and then didn't save it again. But this should just work. Okay, 1 second. All right, so we implemented n00bery and drop, and I just accidentally pasted something into Emacs that I didn't mean to, and we have a clean build. So now we can go to the next thing. Okay, so the next thing Rustonomicon does is it goes into a raw vec implementation, and if you followed along, the actual vec in the standard library uses a raw vec underneath instead of, and then that raw vec kind of handles a lot of the array stuff. 1 second, getting a gate call. Have to let somebody in the gate here. Okay, all done. The magic of technology. Yeah, so I'm not super interested in making this implementation very thick. The whole point is just to understand how Rust manages memory in unsafe blocks. And I think we probably have at this point. I don't see any new stuff in Rustonomicon. Here, I'll just switch over real quick. Let's see. Nope, wrong screen. There we go. So here's the whole raw vec stuff. Here's the drain. Okay, sure. So drain is very similar, except it doesn't consume the vec, right? It borrows it. So I don't actually know the difference between drain and iter. I guess that's the part that I don't get. Like, what's the difference between calling drain and calling iter? I know iter is something we get for free from the dref and from basically converting it into a slice, but that's fine. So this is very interesting, might be useful in the future. And then they go into zero size types, which I'm just not gonna touch right now because I feel like Rust already is going to make our data structure implementations pretty complicated, and I think not supporting ZSTs is a good starting place to just make this a little bit simpler. But this final code, this is their implementation of a vec. So they have a raw vec, and their raw vec just has the new and the grow. I get that they want to put that into a different piece of the code to make it a little bit nicer to work with. And technically the raw vec's the only thing that needs to be dropped, right? And then we have our actual vec. And then here you have your raw vec t and your len. Again, this is exactly how the standard library implements this. I don't mean it's exactly in that it's the same code. I just mean it's the same basic structure. So yeah, that's the end of their implementation of vec. We did most of these things except for drain. It's not like that would be that hard, right? But that's fine. Okay, they do still, right? So then they did still pop everything off, and they're popping everything off so that it gets rid of those values on the stack, and then they have the deallocation. Let me just think about this. All right. So the main reason why they're doing this and why we just wouldn't take that, I think I'm right about this. I could be wrong, but this is my understanding. Like, in some ways I'm like, okay, we're storing this on a contiguous block of memory. Why are we going through and calling self.pop, which again is taking every single thing off the from memory basically and replacing it with a dummy value, if you will, and then instead of just deallocating that whole memory block, right? But basically what they're doing is they're letting whatever t is called drop, and that's why they're doing this. That is my guess. That's my guess. All right. So this is some of the stuff that they used for drain, and I skipped it. I skipped it because, again, that's a full advanced implementation of VEC. I didn't do. Okay, so I think this is enough to move on, and that was my goal. Is can we get enough to move on? And I think we did. So yeah, I think actually maybe a stack is good. It's basically the same logic. It's going to be, but it at least gives us, again, some more practice working with unsafe, making sure we understand this in small little bits, and I think that's helpful. Okay, so let's do it. Do a new file, stack.rs, and the first thing we're gonna do is please allow dead code. We're not good enough to do this without dead code. No, I'm just kidding. It's just because we're not using any of these in our actual program. I don't know why I always... Of course, that's what I did. I'm so dumb. I'm so dumb sometimes. But that's okay. There we go. We know what's happening. And then it's going to say that until we put it in our lib. And that, I mean... Oh my god. My brain. I switched my space and enter keys recently. It's day 3, I think, and I'm still not completely there, especially when I start thinking about other things, like I just typed mod lib because I wasn't thinking. Mod stack, that's what I meant. That's what I meant. Yeah, I know there's nothing in it so far, okay, but there's going to be. It's just because Emacs creates that buffer, saves the fact that you did that, but you have to hit save for it to actually write it to the file system. So now we're good. Nothing on either side. Okay, so let's just write out real quick what our stack implementation is. So for stack, we're going to have a pop and push of O1. And what's our other guarantee on a stack? For the most part, that's our main guarantee, is that you can, I mean, that's our main guarantee, and that's our main interface. Like if you really want to do Git, you could, but for the most part, right, the point of the stack is that we just have pop and push. And of course our, it's last in, first out, right? It's a LIFO. It's a LIFO queue, right? So that's that. Okay, so our stack struct is going to be, might help if it was public. Otherwise, what are we doing? We're not even going to let anybody use this amazing code we're about to write. Pub struct stack. Okay. It's generic over T. And what are we going to have? We're going to have our putter. And this is going to be a non-null. Let's see if I can get my LSP to do this for me. It would be really nice. It did it. Hey, thanks, LSP. It's so sweet of you. Okay, so we're gonna have a non-null pointer over t, and then what else do we care about? We care about the inner capacity. Actually, we know. Hold on a second. Give me a second. We got our pointer. We've got our length, right? We need to know our length. I mean, essentially, we need to know our pointer and our tail. I mean, what's interesting is you could of course just store the pointer of the last element in your buffer in your array. I don't know what I want to do yet, but that's okay. We'll just do a length of view size for now. Whoops. And I'm sure I'm going to need something else that I'm just not thinking about right now. With our pointer to the start and the length, we can know the pointer to the last part of our thing. I guess it's capacity that I would care about. I think it is capacity that I would care about. Let's just no, we'll just keep going because it'll be clear as we implement. So impl t for stack t, and we're going to have our new function which returns stack t, and we'll just define the rest of our functions right now. We're going to have our pop function which returns an option of t, and pop is going to take immutable reference to self. Doesn't need anything else. And we're going to have our push, which takes immutable reference to self, and the item, right? So we are just going to call it item of t, and that's also going to return unit. Okay, I think this is good. We can do, see if I can remember this part from what we just did. We can do this if t implements send. Wrong key. Okay. Impl t send. I want to say it's probably send. Yeah, I think that's right. And then we can do the same thing for sync. Could have just done a find and replace, but that's okay. Who wants to make things easier, right? Okay, sick. All right. So we're getting our stack fleshed out a little bit. We have our new, we have our pop, we have our push. We just implemented send and sync. It was really hard. And again, that's just saying if t implements send and sync, then our stack is type safe. I mean, I'm sorry, thread safe. In that case. fearless concurrency. Okay. Cool. So yeah. So this is where we're gonna need capacity. I knew I was right. I just couldn't think. I couldn't convince myself that I was right. Okay, so capacity is going to be use size, length is use size, and our pointer is not null over t. Okay, so we're basically at, from what I remember, the Rustonomicon point. So, good deals, good deals. Okay, so the first thing that we're going to do is not allocate if we're on our initialization, right? So we can basically just return a stack where our pointer is non-null dangling, and I think, what did we miss? There's something I'm missing here. It's the type. I always forget how this part works. We'll figure it out. We'll just keep going. Yeah, that's fine. And then our cap is going to be 0, and our length is 0. Okay. So let's just write that, and then let's get our compiler to help us a little bit for the things that I'm not remembering perfectly. Add a trait here, impl. Oh, okay. Okay, that's, no, it wasn't supposed to be that. It's just impl. Is it impl t for stack? I did this for array list, so I'll try not to reference the other code, but I will do this. It's just impl t array list t. Okay. I was like, really? It's really funny. Okay. Okay. I thought this would work. What don't you like about this? The trait send requires an unsafe impl. Oh, that's right. These are unsafe. I forgot about that. So this is unsafe, and this is unsafe. Okay. Obviously, pop is not returning an option T. Other than that, it seems like it's actually happy. I guess. Well, let's just return none and make sure it's not hiding some other compiler errors, because sometimes that happens. But no, actually it looks like this is valid code. So our dangling pointer didn't require type annotation like I thought it would. So either it knows just because of where it's going into, like it's calling into on itself, or it's just fine for it to be dangling since there's not actually a value there. I'm not sure which. This is our dangling but well aligned non-null. I did read up quite a bit on alignment, and I'm getting a lot closer. I'm getting a lot closer to understanding it. So, you know, I'm trying here. I'm trying. Okay. So what should we do? Push or pop? I feel like I don't like taking something from an array when I don't even have anything on it, but that also led me to a nice little bug in my array list, right? Anybody else remember that one? It was pretty good. All right. And that was basically, I forgot the the case where we have no elements. Yeah, pretty good. So if self.len equals 0, we need to return none. Isn't that surprising? I think that was the bug I had in my array list. Unbelievable. Okay. So else we do something, right? For now, no, let's think about this. Okay, so if we have our pointer and we have our capacity, we have our length, we are going to take something off of it. So we are going to update our length to minus equals 1. Let's start with that. And then does it not like this? It doesn't matter. It doesn't matter. It's probably just saying I'm not returning an option. That's true. I'm not returning an option. Okay. And then we have our unsafe block where we actually read our pointer. So if I remember right, this is pointer.read, and then we have to, which means here, let's get this imported for us. Nothing. You don't got anything for me? Maybe here? Nope. Okay, that's fine. It's just self up here. Okay. Come on, come on. I know I hit a bunch of random keys I didn't mean to. There we go. Okay, let's see what read takes on a pointer. I thought this was from here. Is that not where a pointer comes from? Okay. Let's just look at it. It is. It's stood pointer. Okay, whatever. It could be because I didn't save, maybe? I don't know. My LSP is not understanding what's happening, but that's fine. Okay, so we have read. I really wish I kind of need this to work. So let's just return none for now. We'll give it a save. And then we'll go back here and say, come on. You still not giving it to me? I know no recursive edit's in progress. Okay. That's annoying. That's annoying. Okay, let's just go over to our VAC and look at read, but then we're basically gonna see the same implementation. All right, let's just look at the docs. I thought it was a good idea, but maybe what I want to do is just like copy some of the operations over. There we go. Pointer. See also, I just want a read. It's possible the read is off of non-null, but I kind of don't think it is. There we go. Read. Reads the value from source without moving it. This leaves the memory and source unchanged. Okay. So it's just read, source const t. Okay, so it's a raw pointer to t. Cool. So I think that's why we should be able to actually take our self dot pointer add offset. Really? I don't know what's going on here. Okay, okay. It's fine. We'll just see what we can do. Self.len. Because we already updated self.len. Okay. And we'll just do this. Still return none. And then see where we're at. Okay, you're not telling me what's actually wrong, so that's always fun. Expected value found module pointer. You might have meant to use the available field self.pointer. I was pretty sure. Okay, I guess you don't have that, so that's not a thing. I was not correct in thinking that that's what we needed to do. Alright, that's fine. I think it might be an as pointer, and then an add offset. I think that might be what we need. We still don't have an add offset. Okay. It's fine. Good times. Good times. Okay. So I know I have a raw pointer here. Oh dear. See, Teeny, this is why you gotta hang out. You know? I know, I was streaming. My schedule just didn't work where I kind of had to stream during Swalker's stream, so sorry about that, Swalker. I'm sorry. Hey Teeny, how you doing? Hope your day's going well. Yeah. So I have no idea how long I was on that other scene without. No, it was recently. It was recently. Pretty darn sure. Okay. So in one way, I wish I could just do a plus, and then I would just have what I wanted. But I'm pretty sure that's not going to be the case. Pretty sure I can't do that. Alright, I have too many parentheses. That's true. You were just at the start of Swalker, yeah. Unsafe Rust is going okay. I spent about the first 40 minutes of the stream finishing going through the Restonomicon stuff, like their VEC implementation. I spent my morning more like reading about all the stuff that I've been trying to understand about, using unsafe Rust and layouts and allocation and alignment, all that good stuff. I think the Wikipedia article on alignment, honestly, was the best explanation. Sometimes that's the truth. Wikipedia is, it's not bad. It's not bad in my opinion. Okay, so we have pointer.read, so I know what I'm trying to do. I just am not remembering the methods to do it, which at one level is disappointing. But right, one is a mute t and one is a u size. And what does read actually take again? It takes the mutable pointer. So I don't know if I can, I don't know if it will do what I want it to. I'm guessing it's not going to work. There was this thing of eye size, and that might have been, I kind of remember this being possibly correct. What do you hate about this? Expected value found module. No. Why are you expecting a value? Is this just like an unsafe Rust thing? Where you just expect values that you shouldn't? Alright. Oh. Oh dear. At least we have capital J on our side. No, I'm still getting it. I'm still getting that. So is my unsafe block just universally incorrect? That doesn't make sense. No, I see that. I see this. Self.len minus equals 1. Okay. Now they have an example right there. There's nothing obviously incorrect about this. Huh. Okay, expected value found module. I'm not seeing a problem. Okay. Time to fall back to our VEC implementation, and let's look at, oh my god, I keep doing this. VEC, and we're gonna look at read. We're not ready. This is true. Alright, so this is our pop implementation in VEC. Basically just looking right at it, but I just couldn't figure it out. Mostly because I felt like my LSP was conspiring against me. Self.pointer. Oh my god, no, it's because I'm dumb. It's because I am dumb. It was not my LSP's fault. I'm calling a method instead of a static, like I did. That was disappointing. That was a little disappointing. That was a very obvious, easy thing to not be dumb about. Okay. This is probably saying this is not the right type. Expected, no, it just hasn't updated. Okay, all good. This isn't the right way to do this. It's the right idea, it's just not the right way to do it. So we are going to do self.puter as puter.add self.len, and that gives us the thing that we really want. And let's see if Rust is happy with us. It is. Okay, cool. So in that case, let's go ahead and I'm being dumb again. There we go. We're just going to put some around here. I don't need the extra line. And I don't need that. More specifically, I really shouldn't have that. Okay, so there's our pop. Yeah, okay, I remembered the basic structure. I just couldn't remember the exact syntax for this read. Okay, so there's our pop, and then we have our push. So push is gonna be different. Okay, so let me think. Do I need to do anything special for the allocation in this case? No, that's handled by grow. Yeah, that's handled by grow. Okay, good deal. Okay, so then we're gonna just push an item onto the end of our array, and so that part's really easy because we're basically going to check first if we have capacity. So if self.cap equals self.len, then we're gonna have to do something, right? Which we haven't implemented yet, but it'll be our grow inner function. Else, not else. That was a mistake. We want to do this regardless. Okay, so if self.cap equals self.len, we need to grow. Otherwise, we can just add it to the end of the array, and after that's done, we can add it to the end of the array anyway, right? So the first thing that we want to do, let's just think about this real quick. So if we had 5 items, we're adding a 6th item. We're going to add that to, let's see. So we want to go ahead and assign that. Right, we're going to add 5. Am I thinking about this correctly? I think so. Yeah. Yeah. Okay. So I think what we want to do first, I might get the order mixed up here, but that's okay. We'll code it out and then we'll talk it out. Okay, so then we have our unsafe, and this is actually going to be not an alloc. This is going to be, let me think about this. I can do this. It's going to be a right. Yeah, so I think it's our pointer right. Yeah. Nice. And that takes a raw pointer and then the actual type, right? So the raw pointer, the place where we want to do this, similarly to the other one, we're going to do an add self.len, and then we're going to have our item. Let's see how happy we are with that. Again, we're going to have to do some tests, especially with this, so, you know, it builds. But since it's unsafe, we don't know if it's correct. We don't have guarantees. Cool. So we write, so let's just make this easy. We have 0 elements, right? And we're writing 1. You know, we're writing the first element in our array or stack. Our pointer, think about this. Yep, our pointer is to the first element. And so we actually want to update length afterwards. pretty sure I'm right. I'm pretty sure I'm right. Right? Because we have 0 elements to start with. We're going to, right, we're adding our first item. We don't want to add anything. We don't want to, if we added length first, then we would end up putting that at an offset of 1 instead of an offset of 0. Yeah, so this makes sense to me. So that's basic push pop, but we didn't implement grow yet, right? So let's go ahead and do that. And then, because without grow, right now, we're actually not doing any capacity. So we can't even write tests as if we, you know, are early in the game. We can't write tests before we write grow. It's basically what it comes down to. We could write the test of initialization and then popping and make sure we get none. We could do that. Sure. Let's do that real quick and then we'll write grow. So we're gonna do a little config test. On test. Come on, I can do this. And let me just jump over here. I always forget if it's called test or tests. I know, ridiculous. I know that's ridiculous. Okay. All right. And we're gonna say use superstar. And then this is our test. Function stack works. And we're going to start with initializing our stack. So we're going to say a stack of, what do we want to do? Let's just do a usize new. Okay. New stack, no elements. And we just want to assert. What? What just happened? Emacs just froze on me. Oh my god, you gotta be kidding me. Emacs, what are you doing? What are you doing with yourself? Come on, come on. I can click around a little bit. Look at this go crazy. This is 1, this is 3. Wow. Emacs really, really shit the bed. Okay. 69. Man. Not super happy about that. Oh, bummer. Come on. Am I back? No? Okay. Let me restart Emacs real quick. I'm gonna have to force close it, aren't I? Sure am. Sure am. Alright. Emacs just couldn't handle. It couldn't handle that out of range 69. It was just too much for it. And I mean, I get it, right? I get it. What? Oh, that's the grep Emacs. So it's not, oh, you gotta be kidding me. It's not in my process list that way. All right, I have to use a freaking GUI. There's probably some other Mackie way that I could have figured this out, but force quit. Boom. Emacs, you're gone. You're gone, Emacs. All right. All the Vim users are laughing at me right now. Oh yeah, let's get the glory of unmodded Emacs. Let's see that start up. Ooh, it's looking good. Can you imagine just like writing on this white, bright white? That would be a lot. That would be a lot for me to handle. Yeah, you guys can make fun of my startup time too. It's fine. It's fine. All right. Call my nice little streaming function here. Get the right size. And that looks pretty good. I think we're back. I think we're back. All right. Yeah. Let's see how much it got. Okay. It has autosave data. We can recover it. There we go. Look at that. Look at those 4 stars. It just didn't like all that swearing. It was mad. Oh man, that was funny. That was a very bad Emacs error there. Okay. What are we actually saying? We're saying assert EQ some let's see, when we pop, no, we want none. We want none when we pop. Darth Unix. You're staying for Rust and Emacs. That's awesome. Fun times. I'll give you a spoiler alert. I am using evil mode. So I mean, if you just like rage quit right now, I get it. I know, perfect timing when Emacs crashes. Were you here for the crash, Darth Unix? That would be funny. It was a good crash. It crashed with some error code of 69, so it was even better. It all worked out. Okay. So I'm sure it's gonna say, but stack use size, it doesn't implement. No, it's not the error it's giving me. All right, let's check this out. Let's do a little testy. Comparison operators can't be changed. I know that, baby. Oh no, I'm dumb. That's not how you do this. Everyone else saw it but me. So embarrassing. So embarrassing. I still forget the syntax. How can I still forget this? Okay. What do? We do stack new and then we do use size? I don't think that's it. All right, let's go to my array list. Goodness, Michael. What is wrong with you? It's just more colons. When in doubt, add more colons. All right, I should know this. I write a Lisp full time, so I should know. No, I did this backwards. I should know that when in doubt, it's kind of like Lisp with parentheses, right? You guys saw that coming. You guys saw it coming. No, that's still wrong. Okay, I know. Oh my god, did you really just crash again? What the fuck is crashing? Is it? What the heck? All right, hold on a second. Is there something like just killing my system right now that's not Emacs? Let me see. Give me a second. Let's look at this together. Maybe you should check the help. Oh my god, what the heck is killing it? I mean, of course OBS is killing my system. That's nothing new. Now playing Touch UI? Are you serious right now? The now playing Touch UI it's taking 8 gigabytes of memory? That can't be real. That can't be real. Tell me I can kill this without just destroying everything. Let's just stop this. No. I'm just gonna force quit. No, it stopped. What the hell was that? Okay. Come on, Emacs. What did... Okay, we're not blaming this on Emacs. We're gonna blame this on my LSP. I think that's fair. Are we agreed? It's not Emacs. It's not Emacs's fault. It's not Emacs's fault that I'm running it on a proprietary system and trying to put an LSP into this whole thing. Killing me. All right, come on. Yeah, it wasn't that time. I didn't have to force quit it though. Rough. That was rough. Okay, we can do this. All right. Here's the... Yeah. Oh, dang it, Teeny. I didn't even think about it. I used that unsafe block, and now look what happened. I probably tested, and I just overwrote like memory on that Emacs was trying to use. You know, that's probably what happened. How funny would that be if I'm just like totally screwing up like random memory blocks? I don't think I can do that. I don't know. I'm not a systems programmer. I'm just pretending. Are you kidding? I'm not really pretending, right? I think you guys all know how far we are in this whole thing. All right. All right. It got my test. This looks fine. Let's just wait for my LSP to start again. Okay, here we go. Maybe we can write this without... Okay, that's all it needed. Oh yeah, I forgot I didn't even get to cannot borrow S as mutable as it is not declared as mutable. Cannot borrow as mutable. Okay, yeah, sure. Yeah. As if. What? Like I just forgot this little thing right here? Unbelievable. All right. Nice. Oh yeah, our VecWorks test. That was just so that we could play with debugging. Let's change that. Actually, I want to change it to something else. I want us to feel good about ourselves. That's how you get all unit tests to pass, right? Isn't that what you guys do for all your unit tests? You just write and assert true at the end of them, and then it's done. Work's done. 100% code coverage. Okay. We wrote our first test for our stack. We have a working pop in our 0 element case. Very hard code to write. So let's jump in. No, I did not say CU1. I said CX1. Sometimes I think Darth Unix might have rage quitted when I said I use evil mode. I think he really did leave. He was mad. I didn't get to tell him, you know, like I used vanilla Emacs. Well, it's not vanilla, let's be real. But, you know, I used Emacs for a long time without evil mode. And I'm just kind of a recent convert, okay? That's really all that went down. Shit, it's already 3:22. You're open-minded. It's funny. Thanks, Darth. Thanks for hanging out. I'm only like, I don't know, 2 months in to evil mode. So far, I kind of like it. TBH. Commenting out failing tests. Right, that's right, Soundle. Isn't that how you're supposed to do it? No, I did it like, the problem with commenting out tests, right, is then you have less like tests passing, so those numbers don't look right. If you just do assert true, look at all these, we have written hundreds of tests. All right, that's great though. Nice O'Reilly book meme. I love it. Okay, so now we're gonna write our grow implementation. Without further ado, let me just tell my partner it's gonna be a little bit, because let's be real, I have to think through some things here. Yay, Mac OS, weird Zoom things. Because if we finish this, our stack is actually done, and that sounds pretty nice. That sounds pretty nice. Okay. Whoops. Oh gosh. Wrong letter. Classic me. Okay. It might help if some of these were actually public, because right now we have a private constructor on our stack, which would be fine if we it would be fine if we didn't care about using outside of this file, but you know, that's funny. All right, it looked wrong when I was about to write what I know is a private function. This is unit, not keep. Oh my god, keep, grow. Why did I want to write keep? What am I thinking about? I'm just thinking about some closureness. Keep is a really nice function in Clojure, by the way. Really nice. Keep is like map, but it filters out nulls for you. Yeah, nulls, null checking. Okay, Darth, I've used Emacs for 30 years along main IDEs. Crashes has happened to me when on Windows, also without evil mode. That's good to know, Darth. No, I mean, Emacs did crash before I used evil mode. I've been using Emacs about 5 years when I started writing Clojure professionally. Because that's kind of like, you know, Clojure's a Lisp. Emacs is kind of like the thing for the Lisps. So really good Clojure support. So it's kind of the recommended. I mean, you can write Clojure in most modern editors, of course, but you know, it's nice to use something that the majority of the ecosystem uses. All right, let me see what my my partner said. That is fine. They're good for now. Okay. Here we go. So what does grow do? We are increasing, right? So again, just like an array list, a stack has a real array underneath, a contiguous block of memory that we need to increase the capacity. And so when it calls grow, we know we want to increase the capacity to something. We're going to go ahead and follow the pattern that Rustonomicon suggested, which is when our capacity is 0, we're actually just going to grow it by 1, and then we're going to grow our capacity by factors of 2, multiples of 2, which makes sense to me. I don't know if this is really why they did it, but one thought is, as far as like memory addresses go and how much space something takes, it's always going to be kind of like, you know, a factor of 2. I don't know if that's really why they did it, but it's an idea. Again, I'm learning a lot of new things all at once. That's my assumption. But either way, maybe it's just more efficient that way. I don't know. I mean, the operation of moving from 1 to 2 is not expensive, right? It's more when you're having to grow your capacity at much higher numbers. That's when it matters. Okay, cool. So we're just going to start with if self.cap equals 0. Then we want our new capacity to be 1. So that tells me a couple things. I remember now. We can just do a little tuple destructuring. New cap, new layout. It's too bad that I'm writing some of this from memory, so sorry if that feels like cheating to some of you. New cap equals self.cap times 2. That should be fine. New cap, I don't know why I'm being dumb. So let's just do a let there. And then this should be a lot easier because, excuse me. I'm stretching and saying excuse me. Just that polite. Okay. We're just going to return a tuple of 1 and then our new layout. So this is layout. Let's see if LSP can help me. Yeah, that is what I want, but I kind of wanted you to put it up there. I kind of think maybe Corfu is having some problem. I don't know if it's really that. Huh, interesting. Very interesting that that's what I did. Okay. It didn't actually do it there. Okay. Let's just go here and see if I can get LSP to just auto import it for me. Nope, it's doing the same thing. That's really weird. That's weird behavior. I kind of think Corfu might be screwing up here. Okay, Corfu is the autocomplete package that I'm using. And now it's cycling. It's cycling 1 of 3. This is bad. This is very bad. No. I'm sure that's just like weird stuff from Corfu, but that's fine. We will just put it up here. We don't need an LSP, right? I also know I'm going to need self from Alec, so let's just do that now. Save us the trouble later of trying to rely on our LSP for anything. Freaking LSPs. I was happy without you. Okay, let's do a new layout. Okay, I really thought that I just specified things. Oh, it's array. Layout array. I knew that part. I know what I'm doing. And then it's new, isn't it? No? Okay. Let's see. Array. Layout array. Use size. Creates a layout describing the record for a TN. Oh, yeah. Okay. So it's similar. It's similar to since you're having to pass the type parameter, it's similar to how you call new down here. I think I'm actually going to do layout array size. I mean T whoops. Oh my god. Nope. Is it like this? Except this needs to be in here. No, that doesn't look right. That can't be it. That can't be it. Okay. Let's try this again. Let's look at docs. How about that? Then we don't have to keep wondering what the heck we're doing. Unless it's exactly like it says in those docs right there. Do I just do this? I think that is what I do. How about it? Okay. Can I just do this? Is this right? Okay. Mismatch closing delimiter? I'm sure that you're wrong. Okay. Interesting. I don't think I did that right. Let's look at docs. Let's look at the layout array. Okay. Stood alloc layout array. Yes. Creates a layout describing the record for a TN on arithmetic over returns layout error. Yes. I know this. Use size. Okay, so that is what I thought, but obviously I'm still calling it wrong. Let's just do this. Usually GPT is right-ish about syntax. How do I use stud layout array T? Let's see. Array, that's what I thought I did. Okay, is that not what I did? Array. Oh, nope, you were right, Teeny. You were right. You think the compiler might tell me. As if. No, I'm just kidding. You were right, I did need another one, and then this we're just unwrapping to begin with. And I'm considering just letting the other one unwrap too. Whoops, nope. I put these in the wrong place. It's right here, I think. Okay. Okay, this looks fine. Now I'm just getting an error that I'm not returning anything in my else block. I recognize those green squigglies. Okay, so we created our new layout. If we have one, if we have two, it's going to be a different issue. We could do the whole thing that they did in Rustonomicon, which is assert that we're not going to hit the layout error where we hit the iSize max. But honestly, I'm just going to let it panic. This isn't to be a, like, use this, I don't know. I guess it's not that hard, right? Okay, fine. We'll do it. Assert. Let's see, what are we asserting? We are asserting that our new cap is less than or equal to eye size, eye size max. Okay, and I need to do new cap as eye size is less than or equal to eye size max. I think this will work. Okay. And then can't I pass a string to assert? I always forget. doc buffer. Can I use a custom message? Where a custom message can be provided with or without arguments for formatting. Okay. Okay, that's what I thought. It's just the second argument. Do I second guess myself a lot? Yes. Yes, I do. Allocation to large. The exclamation points are necessary in case you were wondering. Okay. So let's write this and then see what it hates about this line so much. This should be fine. Obviously, maybe I can just do this instead. Would you like me better if I did this? No, it's just as bad. I know if and else have incompatible types. Okay, maybe that was my only problem this whole time. That would be funny. Okay, so we're asserting that, and then we have to create our layout now that we know. So we already have our new cap. Now we have to create our new layout. And I think, let me think. Was there more to it than this? I don't remember. I think if we had new cap, comma, layout array t, new cap, and dot wrap. Let's see where this gets us. All right, so we're here and we need a semicolon because it's a let statement, and we're good. Okay, sweet. So I think our compiler's happy. We haven't actually done our grow yet, of course. All we've done is we know what our capacity is and we know what our layout is going to be. Okay, so now we actually have to allocate. So the first thing to do is to say if self.cap equals 0, we're going to allocate. And then, of course, if it doesn't equal 0, we have to reallocate, right? So if I remember right, we can kind of use this little guy here. And then we're going to say alloc. Alloc, I want to say it's just alloc, yeah, with layout. Sweet. And obviously we're going to need to capture this pointer, but we'll get there. So we're going to say allocate according to the new layout. Why did I call it new layout? I don't really know. It's a good question. Okay. Else we need to reallocate. And I think it's just called realloc, is it not? Yeah, okay. So this takes our original Oh, okay. Hold on a second. Let me think about this. Realic must be taking the... Let's look at the docs real quick. I'm pretty sure Realic is actually taking the original layout. Function expected to be deprecated. Oh, wow, that was really helpful docs right there. You explained even what all the arguments are and everything. Just kidding. Okay. Goodness me. Okay, it's okay. I'm mostly just... I'm almost certain that we do not want to pass out our new layout, do we? Let me think about this. That wouldn't make sense, because otherwise there's no way of them knowing, right? You're calling a Realic, you're giving it a pointer to the first block in your memory, and then you didn't tell them what size it is or anything. So you must be needing to pass the old layout. So I kind of think what we want to do is change this from being called new layout and just call it layout. And it does feel a little weird in some ways to even bother with some of this. Yeah. It feels a little weird to bother with the way they wrote it, but we can go back to it. Yeah. Yeah, you're right. No, it's definitely true. I don't know what you're saying that exactly in reference to. I mean, it's very similar to our array list implementation, right? But and a vec is an array list, blah blah blah, right? So if you divide all costs by the number of inserts at any point, it turns out to be constant. Thus, it's all O1. Yeah. Yeah, no, I think that's a great point. You might be saying that partly in reference to, like I was saying, oh, it's less expensive or whatever it is. You can do some optimizations. But yeah, no, it's a great point. Completely agree, Soundle. Completely agree. Right now, I was just trying to remember the Realic syntax. But yeah, totally. Okay, so I think what we actually want to do is return our previous capacity in this layout. But that could be wrong. Just give me a second here. We gotta know how this works. I'm not happy not knowing how this works. Okay, so let's go back to docs. Yeah, amortized time. Yeah, exactly, Vivex. Yeah, it's a great point. I mean, obviously you could have a less efficient optimization, like a less efficient way of growing that inner array, right? Where, you know, it's more costly. But yeah, I get it. Yeah, worst case versus usual case, yeah. So yeah, I mean, at worst case, absolutely, if you're pushing something to the end of the stack or array list, whatever, it's not necessarily O1, right? It's not necessarily constant. Yeah, exactly. Yeah, it's good discussions. Okay. What were we going to look up? We were going to look up Alec, Realic. Realic, yes. This is literally all they tell you. They don't even tell you, like, I have to be right though, right? Okay, let's just look at what, okay, that's why. The global realec actually has way more information. We're about, I'm just gonna read this, Vivex. I see your chat. To the given news size in bytes. This block is described by the given pointer, and like, okay. Yep, I'm right. I knew I was right. I was just annoyed that there weren't docs telling me that I was right. It is kind of an interesting way of doing this in one way, in that instead of like saving this layout somewhere, we're creating it new every time. I'm back to code. Okay. So I made the right changes because it does make it a little confusing, because here I'm actually defining a new layout because I'm going to pass it to Alec here, and then in here I'm defining the old layout. So I don't actually like this code because I feel like it's not expressive and it's being used differently depending on where it is. You're just an electrophysicist writing assembly. What do you know? No, just kidding. That's awesome. That's good stuff. I'm just a liberal arts major writing Rust. But I have learned much in my life, being an old man of 38 years. Okay, so cool. Let's write this before it leaves my brain. So we're going to pass self.puter, but we need an as puter because right now it is in the non-null wrapper. Yeah, my brain's not ready for that space switch still. We're gonna just pass our layout, and then we have to pass our new size, which is our new cap. So that's all good. Now, of course, we're not done, because these provide us things. That we need, such as pointers, the actual memory address to where our data is stored. So what we're going to do is just do this. And then let's think through this. We reallocated and copied our memory, all that good stuff. We allocated in the first case, and now we just need to update our actual values. Our length hasn't changed. The only thing that's changed is our pointer and our capacity. So let's see what's still wrong. I know one thing that's wrong is that this is being updated to a raw mutable pointer, and it shouldn't be. There's that one. We want to do a non-null. I'm guessing it's a new. Yep, that looks good. We still have some problems. Expected struct non-null t found enum option non-null. Oh, right. I forgot that these. I forgot that there's an optional here. Okay, so we have to match on that optional. Okay. So this is not. Let's see. What does Alec and Realec return? Function alloc returns that. Function realloc returns that. Let's just build this and see what it says. Yeah, I mean, worst case is really, it's a really important thing to know, right? Okay. Did I just switch to iTerm out of habit? I did. Because I still use iTerm at work. But we're trying to use warp. Why? I don't know. We just are. Remove semicolon. No, I don't. Depends on. Oh, Jesus. Yes. There is a bad semicolon there, isn't there? Is that really all that was? That would be so funny. It's not, but that would be amazing if it really was. Found, okay, expected raw pointer, mute U8, found raw pointer, mute T. Oh, okay, right. So the alloc, yeah, okay, so I should be able to just do an as mute U8. So it needs that binary. Okay, so we're really close actually. Hey Kopil. Thanks for joining again. You've been doing web development for 4 years, and after going from Sublime to VS Code, I just tried WebStorm. Yeah, WebStorm is IntelliJ's for like JS and all that, like basically front end stuff, if I remember right. Yeah, man. I mean, if you are an IDE fan, IntelliJ's products are very good, and you know, I don't have anything bad to say about them. They're great. I I cut my teeth on Eclipse when I started. Yeah, that's sweet. Because I was writing Java. Oh God, I know, Soundle. I'm not a fan. I'm not a fan of the way that all this works. Because you just highlight something, and then I don't know, it annoys the crap out of me. You stick a to-do at the end. It's smart. I haven't written C#, mostly out of just like base irrational hatred of Microsoft. But I'm very familiar with the language, you know. I mean, oh, let's be fair. I have written C#. I did it one time. Because somebody wrote something in C# that, of course, and then left the company. And then I had to maintain it. And they wrote it in C# because it had to run on Windows, blah, 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 blah. That's good to know, Vivax. I've seen people do that. I've never even really thought about using it. That's smart. That is very smart. Because I usually just end up like returning a throwaway type. Like if it returns an optional, I'll just do none. You know, or I'll just say it returns a result of unit, right? But yeah, I started with Java. That was my first backend language 10 years ago or so. I was full stack at the time. Did Java, yeah, no. That's why I prefaced it by base irrational hatred, because obviously, like, Oracle is they're just the fucking worst, aren't they? Aren't they just the worst? It's just hard. It's hard to choose, you know? What an evil choice. And then we have beautiful things developed like Rust, and then people want to be as evil as they can somehow. I don't understand when they don't need to be. Like we have languages outside of like pure corporate control, and then here we go. Yeah, I know. That's amazing, Code Bill. That is an amazing fact. An amazing one. I don't know if I finished kind of my spiel, but yeah, I wrote full stack, did Java, wrote it in Eclipse, eventually moved it over to Visual Studio Code once that came out and was good enough to write Java in. Still pretty early days. And then when I got a job writing Clojure, I tried writing Clojure in Visual Studio Code. You can do it. There's no problem with it. It has great language support for it, but it just felt wrong. And Emacs is kind of the de facto for Clojure, so I started using Emacs then. Nice. That's great info for us Rust noobs in here at Vivex. I appreciate it. Yeah, so I use Emacs now. This is Emacs. I use evil mode. I just started evil mode like 2 months ago. Yeah, close to 2 months ago. Which is basically Vim motions inside Emacs. But before that, I just used Emacs key bindings. And so far, to be honest, I've been kind of liking the Vim motions. I'm probably going to stick with it. VS Code with Vim motions, it's the way to go for something that you just don't have to deal with. One of the really nice things, like, you get, knowing Vim motions, you get, let's switch to a personal view. Oh, really? OBS? I was all excited about it. I went through it, and then you've already killed my key bindings? You gotta be kidding me. Oh, OBS pisses me off sometimes. It's most likely just my system, but it also just sucks on Mac in general. All right, here's our more intimate scene. Yeah, so people say about using Vim, oh, if you know Vim, then you can just like go in and use it on any system, blah, blah, blah. Honestly, if you just know Vim motions, you can pretty much do that as well. So it has been really nice learning Vim motions a lot more purposefully. Like, I knew some of them. I knew how to get around. I knew how to exit Vim. Ooh, the music might have gotten louder. Let's see. Let me see. 24.5 dB. Nope. It's supposed to be the same. Oh, I have VLC double imported in this view. That's hilarious. Okay, hold on. Good call out. Remove. Yes. There we go. That's probably the way the music sounded a little weird. It was doubled. I don't know if OBS actually doubles it when you double it in your view, but yeah, having Vim motions, then it's like, if I'm just making a quick change to like a comp file or something like that, I don't even bother loading it into Emacs. It's just, might as well just do it in Vim or VI. And of course you can do that directly on servers and stuff, which, I do have to do from time to time. Evil mode is nice. I've enjoyed it. I think it's really well done. Some people hate it. I think so far it's really well done. I know a lot of very capable developers that use it. The music was louder than me. That's so weird. Yeah, it's weird because it wasn't showing in my audio mixer. So, oh well. Thanks for calling it out, because I would have never known. There's my meme I decided to load in for today. And this is definitely me. Real talk. Like I said, I've been professionally developing for 10 years. I'm 38. So you can figure out what that means. I had other jobs before I got into software development. And some of those were customer service jobs. And this was pretty close to me in those jobs. So, yeah, good thing I sit behind a computer, right? Don't interface with users directly. It's a very good career choice. Okay, right. I have to manually switch scenes. Fun times. I'm gonna have to Google that one. It's been happening enough that I need to figure it out. It's really annoying. But yeah, good talk. Vim motions for the win. Even if you don't want to use them all the time, just know the basic ones. It makes it easy. Makes it a lot better. Let's see. I said I would be done at 4, and it is 4. I think we are really close to this. Let's see if we can just finish this up in the next couple minutes. Or not. Okay. Expected struck non-null found. Okay, I don't know what this is about, so let's do a little cargo build. Non-null. I probably just called non-null wrong. Expected non-null T found option non-null. Expected struct found enum option non-null new. Oh, okay. So does new return? That's what it is. I knew there was an optional in this flow somewhere, and it's that new returns an option. Sweet. Thanks, Teeny, for the update on that. That's really nice to know. Creates a new non-null if pointer is non-null. Okay, sick. So what we're gonna do, we'll just set self.cap there. Let me see. Is this how I want to do this? If we can't, okay, we'll figure it out. It's fine. Let's do this. No, I didn't need to paste that there. Probably not even gonna do this. We're just gonna do match non-null. Okay. Yeah, match non-null putter, right? I think this is what we want. And if we have a sum putter, whoops, did it again. If we have a sum putter, then we are going to say self.cap, not cap, I was looking at the thing above, self.putter, oh wait, I did this wrong, I'm being dumb, non-null new, that might help. There we go. Yeah. Now you see that little update my LSP just gave me saying you're actually doing the right thing. So then we're gonna say that, and in the none case, I don't know what we want to do. I think it depends on why does this function fail, right? I don't actually know why it fails. Let's see. Creates a new non-null if pointer is non-null. Okay. Yeah, that's probably what it is. You could do a handle alloc error. Yeah, well, what's interesting is in this case, there's not, like, as long as I passed it something correct here, this should never be null. Yeah, I use ChatGPT sometimes. What should we do? Listen in it. Yeah, the whole ChatGPT vision thing. I don't know, man. I really liked, like, 3 years ago, Sam Altman was the best Sam Altman. Clients wishing to abort computation in response to a reallocation error are encouraged to call the handle alloc error function, rather than directly invoking panic or something. But is this because of a reallocation error? That's what I can't figure out. I think we're pretty darn close. Should we just check Rustonomicon and see what they said about this part? Because again, like, yeah, ideally I can do this without any references, but this is our first time. Yeah, right? That would be great. That would be great, code bill. Non-null will return a none on a null pointer, and realloc uses a null pointer to mean error. Okay, that's really good to know. Thanks, Vivax. That kind of takes care of that, right? So then maybe on our none case, that's what we want, right? So if we have a none, then we want to return whatever the heck you said. Okay, I already have alloc in scope, so we're just going to say handle alloc error, and this is for it takes a layout. Okay, we can do that, sure. That should be fine. Yeah, so this is probably just about return. Expected struct non-null 2, found struct non-null U8. That's because I'm returning things here and I don't actually want to. So I think what I have to do is put some curly braces around it and yeah, right. Let me just use up all the memory on my system. It's funny. All right, I am quite a bit late. Let's see. Almost done. Okay. I think we're gonna feel good if we just finish this though. Yeah, exactly. That was my idea. That was what I was about to say before I got distracted by everything in the world. What did I install that finally gave me this wrapping curly brace support that I've been wanting? I don't know. No, I already had the Vim Surround plugin. I don't know how it's just doing it automatically, but I'm a fan. I'm a fan of it. Okay. So yeah, sorry that I don't know. Okay, so if we do this, it shouldn't return anything. And I'm guessing handle alloc error, it does a panic. Do I need to do anything special here, or can it just kind of figure out that that's not a real value? Like, it's just panicking, I don't have to do anything. Let's just do a cargo build. That's not enough information. Oh dear, I really did it. Cargo build. Yeah, right. I did have a program that was using 8 gigs, and I think I have 16 on this system. Okay. Expected non-null T found not. Oh, right. That's right. Now I have to bring this back. Now that I'm doing it here, I have to do this back as a mute T. You like me now? You gonna get a build out of this? We're gonna have to leave tests for another day because I'm already over time. But more info on that type Oh, it's the never. Is that what that is? Yeah. Okay. That's right. That it's the same type you were talking about earlier with the to-do thing. Yeah, that's sweet. That's sweet. Today I learned. Today I learned in Rust. The never type. The never type. Okay. Sick. Well, guys, went a little bit longer than I thought I was going to. And we know it's bug-free because it compiled, right? Even though we used unsafe. Because they assured us that unsafe is safe. Yeah, so we'll write some tests. You know, it's possible that this is bug-free. It's possible. But we'll write some tests next time to make sure that our stack behaves as we want it to. Obviously, the stack is basically just a thinner abstraction than array, right? It's than array list. It's array list with less methods on it, right? But this time we implemented it with unsafe, and yeah, it is. I must confess, I have not a perfect photographic memory, but I do tend to remember things pretty well. And so having just read the Rustonomicon implementation, you can probably tell that I remembered most of it, right? So that's it for today, I think. Thanks so much for hanging out and chatting and watching us figure all these crazy things out. I don't really have time for a raid, so sorry, folks. But yeah, thanks for coming. And we'll see you. Should be tomorrow. Pretty sure I can stream tomorrow. So we're going to write tests for stack tomorrow, and then probably just fix our array list because it did have a couple bugs in it, and then move on to the next data structure. I don't know what it's going to be yet. I actually do. It's a queue. It's going to be very similar. We're going to write a queue. Okay, so I don't know if we'll get into the queue tomorrow, but we'll at least finish tests, fix our array list, maybe get into the queue if we have time. So yeah, thanks a lot for hanging out. If you're new here and you don't follow me, this is what I do. We're going through a bunch of data structures in Rust. We're going to do some algorithms too. You can watch things on YouTube if you really want to. You can get into the playlist on YouTube if you really want to. It's all here on Twitch too. There's no difference. I just post the same videos. GitHub is there, you know, all that good stuff. So thanks so much, and we'll see you guys later.